One of the most tried and true ways in which to secure your data is through network segmentation. But how is that done and what does that look like? Well, that's a topic we're going to cover starting right now.
You're watching IT Pro TV.
Greetings and welcome back to the Security Plus series here at IT Pro TV. Always glad to have you good folks with us. And today we're going to talk a little bit about securing our networks through the means of network segmentation. It'll be a good time. It's a great topic and one that's foundational to your security knowledge base. So I'm glad we're having this conversation with my good friend, Mr. Wes Bryan. Wes, when it comes to network segmentation, would you say this is an important thing or just something you should kind of know about?
It's definitely an important thing, and it's really the foundation of network communication. And we've been doing it for a long, long time. And I want to stress the importance of just understanding the concept and really how it relates to security. And that's why we want to take a little bit of time and talk about the different ways that we can divide our networks up. Let me show you what I mean here. So when we talk about network segmentation, right, you might ask yourself, well, what's one of the reasons we do this, right? Well, we do it for performance. And you might say, well, what does that have to do with security? Well, remember availability. Availability is still one of those pillars of security. And let's take this massive network that we have here. We've got a series of computers, and they need to talk with these, let's say, servers or resources within our network. We've got another series of computers, and maybe they need to speak to, well, just these resources within our networks. Well, the problem is, and can be a problem, is when large networks like this, when you have a lot of devices, you have a lot of computers, you get a lot of resources, well, these computers over here don't just talk amongst themselves, right? We get a lot of extra traffic on our networks, and that can cause performance issues. Now, there's also not only a performance issue, there's also security issues too. And what I mean by that is when you have every device in the network listening to every other device in the network, you have a potential for information to get transmitted between these devices that you don't necessarily want to be transmitted to everybody. So one of the purposes for network segmentation is to help with performance and also security too. So let's talk about what I mean. All right. Let's talk about from the performance standpoint, right? We've got a large network here. We've got the same resources that we've talked about, but now what we do is we divide each of our groups, if you will, of computers that need only those resources in between them into segments. And what happens is, just like before, these computers, they talk with the resources that they need to talk to. The computers on the left-hand side here, they're going to talk to the resources that they need to talk to, but then we don't get that cross-pollination, right? And that's a good thing, right? We are, maybe if you're familiar with things like just basic networking, right? We talk about broadcast storms. We'll talk about switch protection coming up in network security, but this helps to really just streamline the performance of your networks. Isolate those communications with only devices that have a common means of, a common, need to communicate, and isolate that in a way so not every device will hear every other device on the network. And again, bringing down those things like broadcast domains and really just isolating that communication to the series of computers that you need.
I'll tell you, Wes, when I first started learning these concepts as much as you are right now, I got really confused about this because I thought, well, if they've basically broke this out into two networks, now they can't talk to each other. But that's not really the case. They normally don't talk to each other. So if that traffic doesn't need to go over there, then it's not going to. We can make a rule or some sort of configuration that allows them to talk to each other if there is a reason for doing so. But basically what we're saying is, by and large, if your traffic doesn't need to go over there and be looked at, keep it out of that system.
Definitely. So think about back to the earlier days of networking, Dan, when we had everything connected into hubs, right? And hubs, they don't really know any logic, right? There's no logic in them. They're really one of those physical layers. If you think about the OSI model, right? They're one of those physical layer devices, and they really are nothing more than a multi-port repeater, right? A communication comes in one port, automatically gets sent out all other ports. They don't inspect traffic or everything, right? And as you connect more devices and more hubs, you could have one device send out a broadcast communication that was really only intended for just a subset of the computers within that network, but everybody hears it, right? And that can cause those performance issues that ultimately can run contrary to the availability side of the CIA triad.
Yeah, and that kind of pushes you on into your idea of security as well, because you think of that hub situation where everybody's getting everything. Well, now if that if that data isn't in any kind of secured communication, anybody could look at it because it's crossing their wire. So this is really where it pushes us into that security idea, right?
Definitely. Think about somebody plugging into your network, right? And now I'm talking about some kind of rogue, unauthorized, or let's just say it's a user on your network, right? Best of intentions, worst outcomes, right? The problem with that is you can inadvertently leak data. Let's try that again. Inadvertently leak data that you shouldn't really be giving everybody access to. So when we talk about the performance side, this is where that segmentation happens. But it also helps us with the security side, like Dan's already mentioned, right? And there are a couple of different ways that we can do this, all right? And in comparison to the OSI model, one of the ways that we do this is through, at the data link layers, through what are known as VLANs. Virtual local area networks. And I want you to think about how a virtual local area network works, right? Just a local area network, right? When a switch needs to figure out, where to send communication, it's only aware of the devices that are directly connected to its ports, all right? Think of a VLAN as a way to divide a switch's ports up into multiple switches. And that's really what happens here. Now, you might say, well, wait a second, isn't that going to reduce the amount of communication? What if I have to go to another network, right? Well, that's where we can bring in the layer 3 type conversation, right? We're going up the layer 3, the network layer of the OSI model, and we can divide, if you will, and segment through different subnets. And Dan's kind of already mentioned this, and this is where we can apply things like ACLs, access control list, which really just kind of either allow or deny the traffic, even further controlling the communication that happens between virtual local area networks. By adding the routing layer, we can say, all right, well, if you're supposed to communicate across the VLAN, well, let me go ahead and send that information into the router here, and the router will look at its ACL and say, no, I've got a rule right here that says deny that communication. So if I have something like maybe, let's say, for instance, I have a web server and a database server, and I don't want any other computer talking to that device in my network. Well, we could put them into that VLAN. And if we need, let's say, outside e-commerce to come in and talk to that, we can let that through with those ACLs. So that's one of the ways network segmentation can affect your security. But remember, performance is also important too, because as you'll learn in later episodes, we can get into situations where if we have too many communications on our network, it can cripple your network and bring it literally to its knees.
All right. Well, now we've got some really good ideas of what we're talking about when it comes to network segmentation, the basic foundations of that, right? So we're going to just start taking traffic that doesn't need to talk over here and make sure that it doesn't do that unless it absolutely has some sort of one-off reason to do so. And then we can apply some security to that. We've got ACLs that can work in there. You even have switch port security right down on that physical layer. I guess that is in layer 2 as well. It kind of crosses boundaries. You know how they do. They like to dance all over the OSI as they do from time to time. Let's move into the a more higher level view of a larger scale of the network and start talking about DMZs.
Sure.
How do they play into the puzzle? And what do they work for? What do they do?
Absolutely. So when we think of things like the demilitarized zone, I'm not military. I know Dan's military. You can understand in a military aspect what a DMZ is. You have two different countries, right? And maybe there's a warring faction. Maybe there's not a warring faction, right? But we put this, what they call no man's land, in between, right? And well, the DMZs, you might be able to communicate through, but you're not going to have direct access to the borders of each nation, right? A DMZ inside of network security, when we talk about securing our communications, I want you to take that network that we have, right? And I want you to think of internet-based communications. We've got a public network, and we've got what's known as the private network. Private network's your local area network, right? But we also have the internet out there, and we don't want to just give everybody access into our network, right? But there's something in our network that we do kind of want them to have access to, right? Again, I mentioned that term, e-commerce, right? If you think about e-commerce, you have a web server. That web server, if you don't allow public access to it, well, guess what? You go out of business. So what do? All right, we don't want to allow this type of communication. So what we do is we actually create a perimeter network. And this perimeter network is typically done within, you'll see it theoretically and for the concept between two firewalls. A lot of times this isn't two interfaces on the same firewall. And what happens is we take that resource that we want them to have access to and we allow public access, if you will, to that one resource. An example is a web server, right? Now, the person that's on, or entity, if you will, that's on the public network, they can communicate through the forward-facing, the outbound public network, if you will, the forward-facing interface on the firewall, and they can connect, if you will, to the web server. But what they can't do is cross through that boundary into the private network. And this is another place where ACLs come in to play too, because we might put a rule on the internal facing side of that firewall and say, you know what, we want one device, one connection from the DMZ into our network. That might be something like the web server communicating with a back-end database server, right? So in this aspect, we want the web server to communicate with the database server, but we don't want everybody to have access to everything on an internal network. Now, these are called a couple of different names, all right? And it really depends on what you're reading. Perimeter network, screen subnet, I've heard them called. It all boils down to this DMZ. It's a perimeter network outside of your internal private network and forms kind of like a boundary between public and private access, if you will.
Yeah, I always think of Star Trek, actually, the neutral zone, right? Like Wes said, this keeps anybody from accidentally meandering their way over into maybe unfriendly territory, and now you found yourself on the wrong side of the border, and you're going to be in a lot of trouble. You give yourself that buffer zone, and now you can allow those entities to come in there and commingle without the alarms being raised. That's the whole idea. Very good stuff. Now let's talk about VLANs a little bit deeper if we could, because VLANs are a crucial part of creating network segmentation and starting to tease apart our networks into more reliable and safe network systems.
That's right. And that's on the inside of the private network, typically when we're creating these VLANs. So let's take, for instance, right, we've got this artificial boundary, right, this boundary of our network. We've got all of these devices. Now, can you imagine if all these devices, like we said when we started the episode, everybody could talk to everybody? Well, the problem is that causes a lot of congestion within your networks. And you might have a scenario, you see the VoIP phones over there, where the VoIP phones only need to talk to the PBX, the private branch exchange, but you don't want every computer within the network having access potentially to that information. For instance, bringing up a protocol analyzer and start sniffing all the traffic on the network and potentially gain or gather some information that they shouldn't have access to. So what we do is we take our switch, a managed switch, if you will, and we create these, again, logical boundaries in between the computers, the devices within our networks, and these become what are known as VLANs. So we can put a grouping of computers that are connected to the switch in VLAN 10, one in VLAN 20, one in VLAN 30, if you will, VLAN 40. I'm making these numbers up arbitrary. It's really going to be how you configure your switch. Now, what happens here is we have the ability to communicate. These computers that are within the VLANs have the ability to communicate amongst themselves. When they send information into the switch looks at a VLAN tag and says, hey, all right, I see this is information that is bound for VLAN 10. I'll allow that information to be there. Let's go back to that concept of broadcast communication. Let's say that some device in VLAN 10 needs to talk to VLAN, another device in VLAN 10, but it doesn't know where it is, right? So it sends out a broadcast communication. What is the point of sending all of that information across VLANs when it's already in that initial VLAN? So what the switch will do is say, hey, all right, I see a broadcast communication. It's bound for a device within VLAN 10. We'll just leave it there, and we're not going to allow the communication between these VLANs. Now, does that mean that you can't communicate between VLANs? No. Right? This is where that layer 3 comes in. If we need that type of functionality, then we can add the routing capabilities, and when somebody in VLAN 10 needs to talk to somebody in VLAN 40, we pass it up the OSI model. The router inspects its ACL, and if there is an access control entry in there, a rule that says, yes, you can talk to VLAN 40 in this case, well, communication happens. So just think of it really taking all of the technical jargon out of it. I want you to look at each little port panel, if you will, a blade within this switch, if you will. Notice that there's 4 boxes. Now, In reality, a lot of times you'll see the different colors here. In reality, a lot of times what that means is that you'll have a certain series of ports that might be a gigabit interface or might be a 10 gigabit interface if it's a a higher end switch. But imagine each one of those ports, those individual boxes being their own group, and they cannot communicate amongst each other unless we add that layer 3 routing. That's essentially what your virtual local area network is. It's all done within inside your private network in order to divide these computers up in order to increase the performance and allow you to increase the security as well.
Now, Wes, I've also heard that these two specific concepts I want to call out, intranets and extranets, that they can also work for network segmentation and for security. Could you explore that idea for us?
Sure. So if we think of the internet, right, many people are aware of the internet, right? What is an intranet, right? The intranet is essentially a bunch of local area networks all connected together to form this big worldwide grouping of networks, right? But it's public access. Right now, I say public access. You still have to go through an ISP. You don't just get to wake up one day and say, hey, I'm going to connect to the internet, but that's controlled through your ISPs. Now, you might want to use all of those same technologies, just like the internet, but you want to keep those resources internal to your own network, right? We don't want to give public access, if you will, into, let's say, the company web server, right? Where maybe it's got corporate policies, our data, and I know a lot of this is in the cloud today, but the concept still stays the same. So let's take an instance where we have that same network, and what do? Well, we ended up just dividing it up into segments, right? And each one of these segments can communicate no different, and all of that internal communication using all of the technologies that the intranet gives you, right? Again, the internet allows public access, are behind your corporate LAN environment, right? That forms your intranet. It's internal. So that's the intranet itself, all right? But it doesn't allow public access outside of that boundary. Now, the extranet's a little bit different, right? So this ends up becoming your intranet. So now the question would be, if this is your intranet, the heck is an extranet? All right, well, an extranet is now where we're going to take in and some of those WAN links, right, across public networks. And let me give you an example. We've got an intranet 1 here, intranet 2 here, and then we've got our public intranet, all right? And what we do is we set up VPN communications, and we'll talk about VPNs coming up, so we're not going to get too in the woods with VPN tunnels right now. We create these encrypted secure tunnels over a public network, and what happens is we allow the communication between these two intranets, and collectively that becomes what's known as your extranet. All right, now where might you see something like this? Well, I want you to think about a situation where maybe you have two companies, right? All these companies are not competing, excuse me. All these companies have the same goals, right? Maybe you have a manufacturer and you have a supplier. All right, and the manufacturer needs to maybe connect to the supplier's network to kind of see, well, whatever, maybe gather some supplies. So company 1 and company 2 each have their own intranets. We basically create VPN tunnels over a public network, and the whole entire thing becomes an extranet. So again, intranet, all private, no public WAN links, right? The extranet, again, two intranets connected typically with public connections going over a public network.
All right, well, thank you so much for clarifying that, because that stuff can get a little bit tricky. You want to make sure you understand those differences between those different types, and you don't get confused when it comes to the exam. Now, one last thing I want to cover before we call it a show, and that is the idea of traffic segmentation. We've been talking a lot about network segmentation, but we're going to take it down to the traffic level, right?
Definitely. So in the past, we think about communications, we talk about public networks, and then we think about our private communications within our networks, right? Well, they have this term called east to west traffic and north to south, all right? Let me show you what I mean here. So we've got our LAN, we've got the public network, which essentially is the internet. Well, the north to south traffic and the east to west traffic, where does that apply? Well, the north to south traffic is traffic coming into your network and leaving your network, right? And then we have east to west traffic. That east to west traffic is basically what's happening inside of your LAN. These are your server to server, client computer to client computer communications. Now, we typically have some kind of implied trust. inside of our LAN that says, okay, these computers within our networks are secure. We're going to go ahead and trust them. But today's day and age, you really can't say that anymore, right? So how do we protect north and south traffic? Well, we've seen this. We do this with firewalls, network intrusion prevention systems, DMZs, if you will, and a host of other technologies, but these are a lot of the popular ones. East-west traffic, what do? We have VLANs, we have subnets, we have host-based intrusion prevention systems, ACLs, right? What today we typically say is we no longer want to say that everything in our internal network should just be implied trust. Why? Well, if somebody makes their way into your network, what can they do? Well, they can pivot and they can go wherever they want. With that kind of mindset, they can go wherever they want. So what they're implementing today is more of what's known as the zero trust mindset. And what does that mean? It doesn't matter if it's north to south traffic or if it's east to west traffic. We protect the whole thing. We don't just assume anymore that inside of our LANs, behind our firewalls, behind our routers, assume that everything in our LAN is going to be safe and secure. Those assumptions will bring your networks down. That could lead to some kind of attack, if you will. And that's the zero trust model that you might hear about. It means basically trust nobody. So this is a little bit about traffic segmentation. If you haven't heard these terms, east to west traffic or north to south, sometimes you'll hear east to west traffic also talking about, hey, if I've got a data center, this is the communications that happens within my data center. And that north to south, what is leaving and entering the data center outside of our protected boundaries. So a little bit about traffic segmentation.
Great explanations and great information for us when it comes to our Security Plus exam, because we're going to need to know why separating our traffic, why separating out our networks and segmenting them is going to increase security. So that typical network segmentation through VLANing and routing and ACLs, controlling those things, always going to be good for you, as well as the concepts of DMZs and this cool stuff of intranet, extranets, and zero trust. Great stuff for us to be aware of when it comes to securing our networks. That said, it is that time again. That's right. We are out of time, and we must bid you a fond adieu. But until the next time, we hope to see you here on IT Pro TV. Have a great day.
Thank you for watching IT Pro TV.